All right, let's talk about function operations today. We're going to talk about functions, and we've done functions. We've talked about f of x and g of x's and how that's just a fancy y. So now we're going to talk about putting functions together. So let's just go ahead and do that. All right, so operations on functions. Here come the rules. So let f and g be any two functions, and it doesn't have to be f and g. I could use m and n. I can use any letters I want. A new function h, once again, that can be any letter I want, can be defined by performing any of the four basic operations: addition, subtraction, multiplication, or division of f and g. So in the case of this problem here, I'm asking you to add. So we're going to get h of x when we add f of x to g of x. So I've said f of x is 2x, so we're going to write a 2x down. And I've said g of x is this x plus 1 over here. So we're going to add that together, x plus 1. So what do I get? I combine my like terms. I get 3x plus 1. Not too bad. We then need to talk about the domain. The domain of this function, well, is there any x's I can't plug in? In other words, are there any x's, any numbers I can plug in for x that's going to cause me to take a square root or a fourth root or any kind of even root of this problem? Or am I dividing in this problem? And since the answer to both of those is no, then our domain is all real numbers. Remember, that stands for all real numbers. Now, in our second example here, we're going to look at rational functions. So I am now looking at the same, I'm still going to add. So I'm going to add f of x and I'm going to add g of x together. So f of x is 3x to the 1/4 power. And I'm going to add to that negative x to the 1/4 power. Now remember, so long as my exponents are the same, we can add these guys. So I have a 3 here, a negative 1 here. Well, 3 plus a negative 1 is 2. What is that? It's 2x to the 1/4. Now, if you remember from the other day, when you have a fractional exponent, the denominator is the index number from our radical. So I can't have an even number there. If that is an even number, I cannot take the root of a negative number. I can't have a negative x in this case. Any x that's negative is not going to work because I can't take the square root or the fourth root or the sixth root or the eighth root of a negative number. Remember, we did imaginary numbers last chapter. So in our last unit with those negative numbers, we knew we had I. So in the case of this, my domain can't have any negatives. So my x, all the numbers I use that I plug in for x must be bigger than or equal to 0. Example number 2. Let's talk about point number 2, subtraction. So in the case of this, I'm going to create h of x by taking f of x minus g of x. So I'm going to write down the f of x. I'm going to subtract off the g of x. You must put those parentheses around it so that you remember that the minus that's here has to go to both, because this becomes 2x minus 1, or that equals x minus 1. What is my domain? Well, am I doing any division in the problem where I might get a 0 in the denominator? No. Am I taking any roots in this problem? Any even roots, square roots, fourth roots, fifth, sixth roots, eighth roots? No. So my domain in the case of this problem will be all real numbers. Now in the bottom example, we're going to take the f of x, which is the 3x to the 1/4 power. And we're going to subtract the negative x to the 1/4 power. Now, ladies and gentlemen, we've done this often enough in life. What is a minus and a negative together? It's a plus positive. So when I add these guys together, I'm going to get 4x to the 1/4. Once again, I am looking at a fraction with a denominator. That little fraction up there, my fractional exponent, that is telling me that I am taking the fourth root of this. Well, the fourth root tells me that I can't do that if I have a negative number in it. So x for my domain must be greater than or equal to 0. Now let's talk about multiplication. So I'm saying I want you to take f of x times g of x. So we're going to need to distribute here. So 2x squared plus 2x is my answer. once again, let's look at my problem. To find my domain. Am I going to be dividing in this problem? No. Am I going to be taking any square roots or fourth roots or any of those even roots? Am I going to make a radical out of this? No. So my domain is all real numbers. Now I have 3x to the 1/4 times negative x to the 1/4. Well, we know that 3 times negative 1 is negative 3. And x to the 1/4 times x to the 1/4 means I'm adding my exponents, so that's 1/4 plus 1/4, which is 2/4, which is 1/2. So this becomes x to the 1/2. Make note, the denominator of my fractional exponent is still telling me I'm taking a root. I'm taking the square root now of this problem. If that is still even, which means my domain, my x has to be greater than or equal to 0. All right, last problem for today. I have f of x divided by g of x, which means I'm going to take the f of x part over the g of x part. Now, ladies and gentlemen, if you can factor these, so you're able to cancel things out or simplify them, reduce them, all the same, mean the same thing, you need to do that. But in the case of this problem, there's nothing I can do to simplify. You cannot, because this is going to be a question you have right now, you cannot cancel this x and this x. They do not cancel. They do not cancel. You have a plus sign here. And if you cancel them out, it's going to totally change the value of this function. So, you cannot cancel. That is the answer, 2x over x plus 1. My domain now. My domain is all real numbers, but we have an exception. And this exception is whatever number I plug in for x that makes my denominator equal to 0. If you look at that and you don't know, you always take your denominator, and set it equal to 0. So that's what I've done down here. X plus 1 equals 0. So if I subtract 1, I end up with x is negative 1. So the exception to the rule here for my domain, it's all real numbers except negative 1. Because if I plug a negative 1 in here, so 2 times negative 1 over negative 1 plus 1, I end up with 0 in the denominator. And you have learned a long time ago that you cannot divide by 0. So it's all real numbers except that negative 1. Now down here on the bottom example, I have 3x to the 1/4 over negative x to the 1/4. Now mind you, everybody gets excited because we get to cross these out. And we get to say the answer is negative 3. So your gut's going to tell you to tell me that the domain is all real numbers because those x to the 1/4 don't exist anymore. But the problem with that is they did exist when we started the problem. They existed right here and right here. And since they existed when we started the problem, the domain still holds that x has to be greater than or equal to 0. Because I can't, and not even equal to 0, has to be greater than 0. Because if I plug a 0 in down there, I would get 0 in the denominator, which I can't have. And as we all know, I can't have a negative in these radicals that these would make it if I rewrote them. All right, those are your notes for today. You have a worksheet for your homework today, and then we will go over tomorrow a second worksheet where you're going to actually plug some numbers in and do some more work with them. All right.